So, dear students, today I am going to discuss about operation research. Operation research, okay. So, in operation research, I'll discuss you the some of the important models of operation research. And in the first model, I'm going to give you the first model that is important for the examination. I am not taking any guarantee. So the first model I'm going to discuss you is MM1, and that is we can say that infinity and FO. Friends, this FO stands for first in and first out. So this model is a first in and first out model. You know, in the queuing system, what is first in and first out. Okay, so let me discuss the model, and so we'll deal this as a single service channel. Okay, in single service channel we'll deal this model in queuing system. Okay, and exponential service, and you say there is no limit on the system capacity while the customers are served on first in and first out basis. So yes, the solution procedure are as following. First step I am going to discuss you is construction of differential difference equations. Okay, the first step for the construction of this model is construction of differential difference equation. Okay, so let's see. Let Pn be the probability of there are n customers in the system at time t. So Pn, the probability of n customers. Okay, and this suffix n stands for number of customers, and customers in the system. By system I mean queuing system. Okay, at time t, this is the variable, time variable. Okay, so at time t there are n customers, not consumer, customers in the system. This is our supposition, and the probability that there are n customers okay, not in at time t, at time t plus delta. This is increment in the time interval. Okay, firstly the PNT was the probability of n customers in the system at time t, and suppose there is some increment, a small increment in time, and the probability that there are n customers at time t plus delta t can be expressed as the sum of joint probabilities. Okay, joint probabilities of the four mutually exclusive and collectively exhaustive events as follows. Okay, so P and T plus delta T is equal to P and T into P, and this is times of no arrival in delta T time into this is probability of no arrival in delta T time, and this is probability of no service completion in delta T time. Okay, plus P and T stands for the probability of n customers in the system at time T. Okay, so I will not repeat this term again. So probability of one arrival in delta T time into probability of one service completed in delta T time. Okay, plus probability of n plus 1 customers in the system at time interval T into probability of no arrival in delta T time into probability of one service completed in delta T time plus probability of n minus 1 customers at the time interval T into probability of one arrival in the same time interval delta T into probability of no service completion in delta T time. So this can be rewritten as friends, look at P and T plus delta T equal to P and T times of 1 minus lambda delta T plus order of delta T into 1 minus mu delta T plus order of delta T plus P and T into lambda times delta T into mu times delta T plus Pn plus 1T 1 minus lambda delta T plus order of delta T into mu of delta T plus order of delta T plus Pn minus 1T times lambda delta T plus order of delta T, and this into 1 minus mu delta T plus order of delta T. So this will imply that P and T plus delta T minus P and T equals to minus times of lambda plus mu times delta T P and T plus mu times delta T Pn plus 1T plus lambda times delta T Pn minus 1T plus order of delta t. Okay, so since we know that delta t will very small term, so it's very small, very small, so we can neglect delta t square, can be neglected. Okay, and dividing by delta t of the above equation, and already taken discard the delta t tends to 0, so we'll get d upon dt of p and t is nothing but minus times of delta plus mu times p and t plus mu times pn plus 1t and plus lambda times pn minus 1t. Okay, where n is greater than equal to 1. And similarly friends, if there is no any customer in the system at the time t plus delta t, if there is no any customer in the system at time t plus delta t, that means no any customer means n is 0. Okay, so that will give us p0 t plus delta t equal to p0 t into 1 minus lambda times of delta t plus order of delta t plus p1 t mu times delta t plus order of delta t. Okay, and this into 1 minus lambda delta t plus order of delta t. Okay, so this will give us p0 t plus delta t minus p0 of t is equal to minus lambda times delta t p0 t plus mu times delta t p1 t plus order of delta t. So now dividing this equation by delta t on both the sides. Okay, dividing by this, and of course take delta t tends to 0 because delta t is very small time interval. So we'll get this, that d upon dt of p0 t equals to minus lambda times of p0 t plus mu times of p1 t, and n is 0, number of customer is 0 at that time. Okay, so this is the formulation, and you can say construction of the differential difference equation. So this is the first step friends. I am giving the proof or solution or construction of the model 1 mm1 fi fo, and this is the first part of construction of the differential difference equation. Sometimes examiners are interested to take part in giving one portion, that is one step, by mentioning the headline of construction of differential difference equation. They will give you the heading or the question by step name, and they are interested to include one question, numerical question. Okay, and sometimes they give the full model to discuss. So this is the first part, and so be caution, and please take your attention towards this point. I have just told you that sometimes examiner are interested in taking the first part of the model and along with a question. Okay, so this is the first part, and now I am going to discuss you the second part, and second part is second part is simple now, and the step 2, yes, step 2 is deriving the steady state difference equations. So in the steady state, P and T is independent of time T, and lambda is less than mu when T is tending to infinity. That means time tends to infinity. So we can say P and T tends to Pn, and d upon dt of P and T tends to 0 as T tends to infinity. So consequently we can say the from step 1 will reduce to 0 equals to minus times of lambda plus mu Pn plus mu Pn plus 1 plus lambda Pn minus 1 such that n is greater than equal to 1, and this implies minus lambda Pn plus mu P1 for n equals to 0. This constitute the steady differential equation. Okay. In the step 3, we are going to discuss the solution of the steady state difference equation. By iterative methods, we can get Pn plus 1 equals to lambda plus mu upon mu Pn minus lambda upon mu Pn minus 1, where n is greater than equal to 1, and so Pn plus 1 can be given by lambda plus mu upon mu times lambda upon mu raised to power n p naught minus lambda upon mu power n minus 1 p naught, which equal to lambda upon mu power n plus 1 and p naught, that is p0. So by mathematical induction we can solve this, and where p naught is 1 minus lambda upon mu. So the final solution is Pn equals to lambda upon mu raised to n into 1 minus lambda upon mu, which is rho raised to n into 1 minus rho, where rho is just lambda upon mu. Okay, and this is of course less than 1, and n is greater than equal to 0, and so the waiting time, I am giving you the waiting time waiting time distribution for model 1 is psi of w equal to d upon dt of psi w t, which is rho 1 minus rho into mu e power minus mu t 1 minus rho, which equals to lambda 1 minus lambda upon mu e power minus of mu minus lambda t. So this is important for numerical purpose. They will set a numerical question, they may set. Okay, now a very important question is that a TV repairman finds that the time spent on his jobs has an exponential distribution with mean 30 minutes. If he repairs sets in the order in which they come in, and if the arrival of sets is approximately constant with an average rate of 10 per 8-hour day. So what is repairman's expected idle time each day? This is the first part of the question, and the second part they ask is how many jobs are ahead of the average set just brought in. So this is the question that a TV repairman finds that the time spent on his jobs has an exponential distribution with a mean 30 minutes, and if he repairs sets in the order in which they come in, and if the arrival of sets is approximately ponsa with an average rate of 10 per 8-hour day. So what is repairman's expected idle time each day, and how many jobs are ahead of the average set just brought in? So this is the question. So let's see the solution. Solution is very simple. As lambda is given 10 sets per day, and mu is given as 16 sets per day. Therefore rho is 0.625 mu upon lambda, and the probability for the repairman to be idle is that P not equal to 1 minus rho, which is 0.375. So the expected idle time per day is 8 into 0.375, which is 3 hours, and second one, the average expected number of TV sets in the system is given by En equal to rho upon 1 minus rho, which gives 5 upon 3, which is approximately, we can say, approximately 2 hours. Okay, two TV sets. Okay, 2 sets. Okay, now the second important question I'm going to discuss you is that the rate of arrival of customers at a public telephone booth follows Poisson distribution. Okay, with an average time of 10 minutes. Time of 10 minutes between one customer and the next, and the distribution of a phone call is assumed to follow exponential distribution with mean time of 3 minutes. Okay, and the first part of the question is that what so the first part of the question is what is the probability that a person arriving at the booth will have to wait, and the second one is what is the average length of the non-empty queues, okay, queues, okay, queues that form from time to time. The third one is the Mahanagar Telephone Nigam Limited will install a second booth when it is convinced that the customer would expect waiting for at least 3 minutes for their turn to make a call. So by how much time should the flow of customers increase in order to justify a second booth? And the answer of the first question is 0.3 and the 0.3 in the first question, and the second is 1.43, and the third will third will be 10 customers per hour. Okay, 10 customers per hour to justify the second booth. And they may ask to estimate the fraction of a day that the phone will be in use, so that will be the exponential and tedious job. Okay, so that will give you 0.3, that will give you 0.3. And if they will ask what is the probability that it will take him more than 10 minutes altogether to wait for a phone and complete his call, then that will be 0.03, and this shows that 3% of the arrivals on an average will have to wait for 10 minutes or more before they can use. Okay, 3%, that means 0.03 means. So dear friends, I am again telling the question, repeating the question. The rate of arrival of customers at a public telephone booth follows Poisson distribution with an average time of 10 minutes between one customer and the next. The duration of a phone call is assumed to follow exponential distribution with mean time of 3 minutes. So first question is, what is the probability that a person arriving at the booth will have to wait? And the second one is, what is the average length of the non-empty quiz that form from time to time? And the third one is, the Mahanagar Telephone Nigam Limited will install a second booth when it is convinced that the customers would expect waiting for at least 3 minutes for their turn to make a call. By how much time should the flow of customers increase in order to justify a second booth? So I hope these are the important question from the chapter queuing theory. So, and I am sure that you will get one full question or may two questions from this portion only, and this will be sufficient to score higher marks. And some objectives, that means short type questions, will be designed from the theory I have just given you, and you will be definitely able to answer those theories in the examination. So please must watch this explanation and theory and numericals before going to examination. So I hope this will lead you to success and score higher marks, because these are very important and sure shot, you can say. I'm not taking guarantee, but yes, this is my experience and this is my analysis. In the previous lecture of fuzzy set, I have given you the questions in a way that is exactly asked in that way, and some students have watched and they are benefited. So not only in this district but other districts students are also watching my videos, and they are getting that means they are able to solve the problems in examination. So please share the channel and share this video and watch this video, and please subscribe my channel, because I am doing something for you. So you think of me and subscribe and share. That's all friends. I will come back in the next video lecture and in the next time with a new topic, with a important topic that may change your life, that may change your success, that may change your yes, your labor to a good direction, to a better direction, to score you higher marks in the examinations. So be healthy, be safe, and take care. Bye bye.